With that, let's move on to the last question using this quadratic model. The last question here states this: how far had the baseball traveled horizontally when its height was 34 feet? So again, we're asked to find something, but we're also given something. The question is, what are we asked to find? In this case, we are asked to find how far had the baseball traveled horizontally. Back up top, we had identified horizontal distance as our independent variable. So in this case, our independent variable h, which is horizontal distance, is what we're, or x, sorry, not h, x, is what we're supposed to be finding. We need to find x. This is what we do not know. However, we're given some information. We're given that the height was 34 feet. Well, height, if we go back up here, was our dependent variable. Right. So we're given that h is equal to 34 feet. If we take a look at our original model of h of x is equal to negative 0.004 x squared plus 1.12x plus 3, we are going to end up taking this value of h and plugging it in for that independent or the dependent variable. So it ends up looking like this. It ends up looking like 34 is equal to negative 0.004 times x squared plus 1.12 times x plus 3. So in this case, we're plugging a value in for the dependent variable rather than the independent variable, which means that it's not simply evaluating the right side of the equation to figure out what h equals. In this case, we need to figure out what x equals, which means we're solving a quadratic equation. Well, factoring is out of the question because of the decimals that we're dealing with. The best approach for this would be to use the quadratic formula. But in order to use the quadratic formula, we need to make sure that our equation is set equal to 0. So to do that, I'm going to subtract 34 from both sides. This ends up giving us 0 is equal to negative 0.004 x squared plus 1.12 times x, and that gives us minus 31. So our quadratic equation is now set equal to 0. Let's identify our value of a. That would be here, the negative 0.004. Let's identify the value of b. That would be this value here, the 1.12. And lastly, the value of c. The value of c is negative 31. Negative 31. Now we know that our quadratic formula says that x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2 times a. So plugging in the values that we have for a, b, and c here produces x is equal to negative 1.12 plus and minus the square root of 1.12 squared minus 4 times a, which is negative 0.004, times c, which is negative 31. And all of this is divided by 2 times a being negative 0.004. So we have everything plugged in where it belongs. Now it's just a matter of simplifying. So to simplify this, we have x equals negative 1.12 plus or minus. Now I'm going to get my calculator back out, and I'm going to plug in all of the square root at once. I'm going to do it very carefully though. So I'm going to go second square root. I got to turn on first. We'll clear that entry out. So second square root, and in parentheses 1.12 squared minus 4 times negative 0.004 times negative 31. So all of that under the square root, hit enter, and we get 0.87 is what we'll round it to, 0.87. And all of that is divided by, well, if I do the multiplication in the denominator, I end up with negative 0.008. Good. Well, we're not quite done. We need to get 2 final answers out of this. So what we'll do is we'll end up getting decimal approximations for each of these. So we're going to do our negative 1.12 plus 0.87. Hit enter. We're going to divide that by negative 0.008. We're going to get 31.25. And now we have to do the subtraction. We have to do negative 1.12 minus 0.87. Hit enter. Whatever that is, divide that by negative 0.008. And in this case, we come up with 248.75. 248.75. So we have 2 solutions here. The question is, which solution is correct, or are they both correct? Let's go back to the scenario really quick to discuss. It says, how far had the ball traveled horizontally when its height was 34 feet? If we think about this, we'll actually notice that both answers are correct. If you think about the travel, let's get a base here. This is the ground. And if we then hit the ball, there's actually 2 locations at which the height will be 34 feet. It'll reach 34 feet on its way up, but then there's another point at which it'll be 34 feet in the air on its way down. So both solutions give valid answers because the ball is in 2 different locations. At 2 different locations, it's 34 feet in the air on its way up and on its way down. So we would say 31.25 feet and 248.75 feet are the 2 locations, the 2 horizontal distances at which our baseball is 34 feet in the air.